Good morning, everybody. We started the second day of the D-Day event, and this morning we will have a few presentations given by the students of Industrial Innovation Engineering. The first candidate of this morning is Miss Laura Ferrari. She's not here, she's abroad, but she has provided a video, so we will watch this video, and after that we will listen to the talk given by Mr. Lorenzo Fantesini.
Good morning to everybody. In this presentation, I will show the research activities that I have done during my PhD studies. My work regards the analysis of geolocalized data with a focus on both environment and user-centric applications in the smart city scenario. Our environment is composed by people, but also by our electronic devices that are always producing lots of data about us and our habits. This schema shows how pervasive technologies datasets fit in the smart city scenario. The human behavior might be captured by pervasive technologies and can be stored in mobility datasets. This human behavior shows how people use the built environment, the natural environment, and the services offered by a city. Such information can be used to reshape the city and for management and planning purposes. In this presentation, I will first give a general overview of mobility data and the related arising challenges. Then, I will show the research work of my PhD studies with the aim of showing possible approaches to tackle the above challenges. Finally, I will show some open direction for future work. The widespread adoption of mobile devices and the diffusion of technologies able to detect the position of the user are rapidly growing. Thus, also the number of whereabouts data is rapidly growing, and this is shown by the plethora of services that detect the position of the user. Some of these applications are, for example, Google Latitude or Foursquare or Facebook Places. A plethora of applications can be built upon the analysis of this kind of data. In particular, novel applications rely on the fact that mobility data is a means to gather information about users and their environment. Thus, two different types of analysis and constantly application may be done, user-centric and environment-centric. User-centric applications are focused on the user itself. Some examples are for personalized tourist recommendation or personalized navigation, live logging, and so on. While environment-centric applications are focused on the environment. For example, events can be identified from mobility data, but more in general, these applications are very useful for urban planning and disaster recovery scenarios. The main theoretical challenge regards how to get useful information from geolocalized raw data. For example, given these logs of GPS traces, how it is possible to derive interesting patterns from a user and thus to code personalized advertisement? Or given these geotagged photos coming from Flickr, how it is possible to identify the main point of interest when they look like a big blob? The main practical challenge regards how to get the dataset and how to get ground truth information. More in general, geolocalized raw data can be divided into two groups: long-term mobility traces, where the user is tracked 24 hours per day and 7 days per week, or short-term mobility traces, where the user is tracked only during specific activities. In particular, long-term mobility traces are often dedicated datasets with strong privacy issues and are much geared toward user-centered application. While short-term mobility traces are often third-party data, but it is hard to get ground truth data. They are much geared towards environment-centered application. Finally, lots of privacy issues arise in the analysis of mobility data, and novel analysis and application have to provide useful information while preserving the privacy of the user. Now, I show the research activities of my PhD studies with the aim of showing possible approaches to tackle the above challenges. The first group of works regards the whereabouts diary. In this case, the dataset at hand is useful logs of the user traces. Several sources of data have been mined: the Reality Mining dataset, Google Latitude data, or telecom data. Data mining techniques can be applied on such data to detect the main places visited by the user, for example the home and workplaces, as long as the main recurrent patterns. Typical individual patterns can be represented by the sequence of places visited by the user. For example, the top part of this image represents a typical weekday pattern where the user goes from home to work, and during lunchtime she goes to the gym and then comes back to work. Individual data can be aggregated, thus allowing to derive group behaviors. The image shows the typical weekday patterns obtained from Twitter geolocalized data. The pattern shows how people using Twitter goes from Nolita district to the south part of the city and then around Central Park. The results of this analysis can be used in social networks to share their own experience and be more informed on the habits. For example, a pattern can be shared as a post on the Facebook wall. The second group of works regards geolocalized sporting data. The dataset at hand in this work has been the Nokia Sport Tracker data, which is a large dataset of sport-annotated GPS activities. Given its large amount of data, computational problems have been arisen, with the need of spatial indexes and pre-computation. Kernel density estimation has been applied to detect the most popular areas for a given sport activity in a given time frame. The results have been collected in the website mysportpulse.com. Such analysis can be used, for example, to understand in which areas of the city age group users prefer to do a given sport activity. Moreover, in the cycling case, we can compare kernel density estimation with the kernel density obtained using the bike routes of the city, with the aim of understanding if people use bike routes or try to avoid them. Then, Pearson correlation can be applied between the two distributions. Given the absence of ground truth, we have also compared Nokia Sport Tracker results with other dataset looking for correlation, for example, mapmyrun.com. The third group of works is about the detection of events from GSM data. This image shows for each day of the week the box plot representing the average value of Erlang data on an area with a shopping mall. Dots represent outliers. In particular, dots above the box plot represent days which are unusually crowded. For example, the Sundays of December represent special openings, while dots under the box plot represent festivities, i.e. days unusually less crowded. The last group of work is about the analysis of the public urban transportation using pervasive mobility data. In this field of research, we propose this general system. Through a user interface, the system receives as input which elements of the network need to be improved, and with which optimization criteria. The ranking module needs several information: network information, the traveler demands, and updated information coming from the journey planner. The output of the system are the best transportation infrastructure investments. Looking at the best improvements for people with disabilities, we analyze the cities of London and Washington, D.C. We have found which station, once made accessible, produce the best benefits for people with disabilities. Which are the future challenges of all this work? The first challenge is how to go beyond one dataset, one algorithm, while the second challenge regards how to move from sensing to acting. In fact, usually this type of analysis uses one dataset and apply one algorithm on the given dataset. Different datasets need different algorithms. The main challenge will be to build a general framework able to receive several datasets as input and able to apply several algorithms according to the expected results. We made some steps towards this object with the project Mr. Tip, funded by Telecom Italia, with the aim of combining different geolocalized datasets and trying to complement each other. Usually, this field of research is based on sensing what's happening to better understand via data analysis the city and social dynamics. But the next step will be adding a third circle, which is steering, and thus closing the loop that enables finalized urban behavior possible. Thanks for your attention.
Okay, now we start real presentations, and the first one was given by Mr. Lorenzo Fantesini. Microphone. Okay.
Okay. Okay.